Good afternoon, everyone. So today, we're going to continue with, I think we started notes a little bit with matrix inverses. We'll continue with that. And whatever we don't get to finish, we can finish that on Monday. And we can also start quiz review on Monday. Tuesday, more quiz review. Wednesdays are our quiz. Also, we'll be checking your notes and your classwork that we've gone through over the course of these days this week. So going to page 9 of your packet. Oh, this is what I wanted to ask you guys. Can you guys raise your hand if you would like a copy of the packet? Because I know that some of you guys may have already printed out the packet, but those of you who are just printing it day by day, yeah, just raise your hand. I just want to get an idea as to how many packets to print out for you all.
I can't raise my hand on my phone, but
okay, thank you.
Copy.
Okay, about 16. Okay, thanks everyone. That helps. Okay, I got you guys now. We didn't quite finish this one. I did this in the 7th period, but I'll go over the details here. At the bottom of the page, we talked about how if I can multiply two matrices together, and if I can get that to show up to be an identity matrix, that means essentially it's the same thing as, it's a similar thing as multiplying a number by its inverse. I'm going to get a 1 in return. So if I multiply a matrix by its inverse, I'll get a quote unquote 1. This is the matrix version of 1 will be an identity matrix 1, 0, 0, 1. So I think we were able to discover that with this multiplying these two matrices together, matrix A times matrix B. I can pair the diagonal from left to right for my first matrix, the columns for my second matrix, and I'm able to work my way through and see that I get 1, 0, 0, 1. Okay, so therefore, matrix A and B are inverses of each other because I'm able to produce an identity matrix when I multiply the two of them. Okay. This next one, I'll walk us through it. If I want to multiply matrix C and D, I just want to know if I can get this to look like a 3 by 3 identity matrix, then I know that C and D must be inverses of each other because they are essentially canceling each other out to make its way down to this identity matrix. Okay, so let's go through the steps here. Here is matrix C. Here's matrix D, all kind of spread out, so I can keep track of the values a little bit easier and match where they're supposed to go. Okay, so if I multiply this, so I get 6 times -1, or -1 times -6, 1 times 11, 2 times -2. Okay, And -6 times -1, 0 times 11, 3 times -2, -6 times -1, -2 times 11, -8 times -2. Okay, and we just repeat the process for each of these, making sure that they go in their correct element spots. Right? We'll go here. -3, 10, -8. Okay, we do our cleanup. It looks like it was on its way to becoming an identity matrix, but then we got stuck with this last term. This third row, third column gave us a -1. So this is not quite an identity matrix. So we say that C and D are not inverses of each other because when we multiply them, we're not able to get everything to cancel out to make it look like a true 3x3 identity matrix. Okay, any questions with this portion from page 9? So now we know what it takes for two matrices to be an inverse. We know that if we were to multiply the two matrices together, we will get an identity matrix if they are truly inverses. But now the next question is, what if we just know the first matrix and we want to produce a second matrix that is the inverse? Okay, so we know what it takes to confirm that two matrices are inverses, but how do we create the second matrix from the first one in order to make them inverses of each other? So that's what we're going to work towards. Okay. We're going to work towards taking a matrix, either 2x2, or right now we're just doing 2x2s, taking a 2x2 and creating the inverse just from what we see given to us. Okay. Now, there are a couple of things involved in order to produce the inverse of a matrix. And the first thing that's involved is knowing how to get to a determinant. Okay, so determinant is just an important component of finding an inverse of a matrix. Okay, so if you guys can write that here, determinant. Okay. A determinant is an important component for finding an inverse of a matrix. So here's how we find the determinant. There's a two-step process in order to find the inverse. We're just kind of going through this first portion first. A determinant is found by kind of, in a sense, kind of cross-multiplying the diagonals of the 2x2 matrix. So let's say a matrix has the form of A, B, C, and D. So what we do is we're going to basically multiply the diagonals, starting with the upper left corner, A times D minus B times C. So that's the formula for determinant. A times D minus B times C. This is a pretty straightforward formula, but I do want to point something out that is easy to make a mistake with, and that is making sure that we keep track of the negative. So sometimes your B times C is going to produce a negative all on its own, and that means that this negative is going to end up canceling out and making this term a positive. Okay, so we want to make sure that we keep track of the negative. Sometimes the B and C has a negative already, and if that's the case, that will take out this, that will negate this negative here. So the negative here is separate from the B and the C value. So sometimes the B and C may produce its own negative. If it does, we don't want to assume that it's all just going to be negative. We got to keep track of all of our negatives in our formula. Okay, so let's practice finding determinant, which is just one component of finding an inverse. So let's say here's matrix E. Matrix E is given as 6, 1, negative 2, 5. It's 2 by 2 matrix. The notation for determinant is determinant det parentheses E, just to indicate that we're trying to find the determinant of this named matrix E. So we start at the upper left corner and then subtracting out the other diagonal. So here we have to be careful, right? Because the negative is coming from the negative from the 2 from this C value, but then there's also another negative here that's part of the formula. So this will end up being 30 plus 2, right? We don't want to just assume that this is always going to be negative. The 2 negatives here will cancel out to be a positive. So. Any questions so far? Next page, we're going to talk about how the determinant is being used to help produce the inverse. We haven't found the inverse yet. We just need to learn how to find the determinant because it is used to find the inverse of a matrix. Okay, let's practice with another one, matrix F. Another way to represent determinant is to use kind of these absolute value bars. So absolute value, or this is also, we don't say this absolute value of F, we say this is the determinant of F. So you can just want to kind of show that there are two major notations to indicate that you're talking about the determinant. So again, AD minus BC, we start at the upper left corner, multiply the diagonal, and then move on to the other diagonal. Okay, we get negative 18 plus 18, which is 0. So here for matrix F, we get a determinant of 0. 0 has a special property. I'll talk about this on the next page, but basically this is saying that if you have a determinant of 0, this tells us that an inverse does not exist. Okay, so right now we can just put that as a side note, but we will get to this when we learn more fully about how to create the inverse of a matrix. But this is just an important component. Are we okay with finding determinant? Okay, let's go to the next page, page 10. I'm going to skip over 1 and 2 because this is just basically repeating what we did with the previous problems here, where we're just multiplying the two matrices to see if they either produce a 2x2 identity matrix or a 3x3 identity matrix. Okay, so we're just going to skip that for now. Okay, this is just kind of a rehash of the previous page. Okay, let's practice a bit more with determinants, and then we'll move on to the next page where we're going to where we can find out fully how to find a inverse. Okay, so let's say all of this is matrix A here, so that we can kind of just have a name for each of these determinants. Okay, so go ahead and try this. Again, the formula is just AD minus BC. I'll do number 3 and then see if you guys can follow suit with 4 through 6. All right, any questions with process to find determinant? All right, let's get really comfortable with finding determinants. And then the next page, we will fully go into how to find an inverse. Okay, spend a minute and then I'll go through the answers. All right, let's check our answers. Okay, any questions with 3 through 6? All right, no questions. Let's go to the next page, page 11. Okay. Matrix inverses. Let's go through some big ideas here, and then we'll go through and talk about the formula to find the inverse of a matrix. Things to know. Matrix multiplicative identity is where I can multiply a matrix by 1, 0, 0, 1 and get back to my original matrix. I can put that identity matrix either after or before. Either way, I'm going to be I'm going to end up with this the initial matrix. And we just learned about determinants. Determinant is the value used to find the inverse. Now, the inverse of a matrix is identified or used by this using this looks like a negative exponent. Okay, either this, or you can write it like this. Okay. We're really not going to use this negative exponent. It's just really a notation for notation purposes. So if I am able to truly find the inverse of a matrix, then if I multiply the inverse of a matrix with the original matrix, then they should have a way of canceling each other out to give me an identity matrix, right? Like how we discovered when we're multiplying two matrices together to see if it'll produce a 1, 0, 0, 1, right? So identity matrix is basically this 1, 0, 0, 1 matrix, assuming that we're dealing with a 2 by 2, which for now we're going to spend most of our time just dealing with a 2 by 2 matrix. Okay, so a couple of vocabulary terms to know. Finding inverse of a matrix is considered non-singular if it has an inverse, and singular if it does not have an inverse. Okay, and the way that we can tell is we look to see what the determinant gives us. If the determinant is equal to 0, that means the matrix is singular and does not have an inverse. Okay. If the determinant is 0, that means the matrix is considered singular and does not have an inverse. But if the determinant is any other number, could be 3, could be 5, could be -6, could be -1/2, then it's non-singular and it does have an inverse. Okay, so here's the formula. If I have a matrix, a 2 by 2 matrix, and if I want to find the inverse, here's the formula. The formula is 1 over the determinant. We already know how to find the determinant, right? It's AD minus BC. We're gonna find that number and we're gonna put it in the denominator of a fraction. 1 over that number. Okay. Multiplied by, so this is only one component of finding the inverse. Now we have to do some rearranging with these values here. Okay, so what's going to happen is we're going to take the diagonal that we were working with initially at the beginning, the first diagonal that we started off with the determinant. We're going to take them and we're going to make them swap places. Okay, so whatever this location in this first row, first column is going to go to this second row, second column. Okay, and then this value is going to take the place of A. So we're going to just make these two swap places. Now the other diagonal, we're not going to make them swap places, but we're going to make them change signs. So -C and -B. Okay. I want to make sure that we understand what this negative means. This negative means that doesn't mean that you're always going to get a negative in your determinant. What the negative means is that you're going to be changing the signs of your B and C. Okay, so when you see this formula in front of you, don't just assume that these mean we're always looking at negative values. Okay, this is only negative with it's only negative in relation to the original, right? The negative means it's the opposite of the original. So if your matrix, if your C value starts off as a negative, then it'll turn to a positive. Okay. Right. So let's go through these examples slowly and see if all this is going to make sense. Okay, so let's think of it as a two-step process. If we want to find the inverse of a matrix, let's spend the time to find the determinant first, and then we'll use that determinant to put it in the form of finding an inverse. Okay, so number one, let's find the determinant first. That's going to be an important component. So starting at the upper left corner, we start off with that diagonal, A times D minus B times C. Eight plus 12 is 20. So now that we have our determinant value, we can now work towards finding the inverse. Okay, so now inverse. So we're going to say A, that notation to indicate that we're dealing with the inverse. And we're just going to follow what the formula says. Okay, 1 over our determinant, so 1 over 1/20th, basically is going to be a coefficient value in front. And we're going to do some rearranging of our original matrix. We're going to make these two values swap places. So AD will turn to D and A. So we're going to make these two values swap places. The 2 will become a 4. The 4 will become a 2. Now the other diagonal, we're not going to make them swap places, but we will force a sign change. So this 4 will turn itself into a -4. And this -3 will turn itself into a +3. Okay, so we're changing the signs of this other diagonal. We're going to continue cleaning up. We're going to distribute this fraction through the matrix. So multiply each number by this fraction. So 4 times 1/20th becomes 4 over 20. -4 times 1 over 20 becomes -4 over 20. 3 times 1/20th becomes 3 over 20. And then 2 times 1 over 20 becomes 2 over 20. Continue reducing. This becomes 1/5, -1/5. 3 over 20 doesn't reduce, so it stays. And 2 over 20 becomes 1/10. Okay, multiple steps involved in finding an inverse. Any questions so far?
No, sir.
Okay. Okay, we're going to take our time with this. I know that there's a lot going on, so I'll go through each problem step by step. Okay. The problem here at the bottom is a little bit more involved. We'll skip this for now. We'll do the easier ones on the back page, and then if we have time, we'll come back to this. But if not, I can also, it'd be good to also see you guys in person and walk through these types of concepts as well. Okay, but right now, let's just make sure we can get this really comfortable in terms of understanding the process here. Okay, let's look at number 2. Matrix B, start off with finding an inverse. Sorry, start off with finding a determinant. Right, that's the first component that we need. AD minus BC. Okay, what do you notice here? What's our determinant?
0.
What does that tell us?
There's no inverse.
No inverse, okay? No inverse for matrix B. Because the matrix is singular. Now, look at the formula for inverse. Can you guys come to a reasoning why there is no inverse? Why is that 0 not going to work with the formula that we have in front of us?
You can't divide by 0.
Can't divide by 0. If we tried to do an inverse procedure, we're going to run into an issue, right? Because the formula says 1 over 0. I mean, we can go through all the steps of changing everything, the AD and the BC, but we're going to be stuck with not being able algebraically to move forward, because if I multiply everything through by 1 over 0, first step, 1 over 0 doesn't exist. Okay, so that's the reason why. Okay, any other number is okay. It's just that 0 is going to cause an issue, and that's why if you see determinant of 0, you can just go ahead and stop and say, okay, I'm not going to be able to make any progress. By matrix, it has no inverse, and if it doesn't have an inverse, we give it a name. It's a singular matrix. Okay, number 3. Determinant first. AD minus BC. Same issue, right? Same issue between 2 and 3. No inverse exists for matrix C either. All right, go ahead and try the steps for number 4. This one, you will get an inverse, and see if you're able to use number 1 as a model for the steps you're going to take. And then we'll compare our answers and see how you guys did. If you're able to go through number 4 on your own, that should give you confidence that that you're getting a handle on finding inverse of a matrix. Okay, so try number 4 on your own, and I'll walk through the steps after you guys try. Okay, start off with our determinant. Four minus a negative 6, so that's 4 plus 6. It's 10. Once you have your determinant, put it in the denominator of your fraction outside the matrix. Use the notation to indicate that you are about to find the inverse of matrix D. And now do your rearranging of your original matrix. Your first diagonal that you started with your determinant, you're going to make them swap places. If I swap 2 and 2, it doesn't look like it's going to change because they're the same numbers. Okay, so once you have taken care of your first diagonal, go to your other diagonal. But now you're not going to make these swap places, but rather you're going to make them change signs. So this 2 is positive. We're going to force it to be a negative. This value is negative. We're going to force it to be a positive. Multiply every number by 1/10. Any questions with this inverse matrix here? Now, what if we were to spend the time, we're not going to do that right now, but what if we were to spend the time to multiply D and inverse D together? What would we get if we were to multiply these two matrices together? Okay, what did we talk about before? If I were to multiply a matrix by its inverse, they're going to cancel each other out, right? So what's going to be left?
The identity matrix.
Good. Identity matrix. 1, 0, 0, 1. Okay, so I just wanted to bring it full circle here that we spent the time to find the inverse matrix. It's a little bit more complicated, but it goes back to what we were doing before, right? We can always confirm a matrix and its inverse are truly inverses of each other, because if we were to multiply them together, we should be able to arrive at the matrix version of 1. It's like multiplying 4 by 1/4, right? 4 by 1/4, we get 1. So if we were to multiply matrix D by its true inverse, they're going to cancel each other out, and the canceled out version is the identity matrix, which is 1, 0, 0, 1. All right, next example is a little bit more involved, a little bit more stuff going on. I'll save this for Monday, but I'd like for us to get some more practice getting comfortable with finding inverses. Okay, so let's go to the next page, page 12. Let's just do 1 through 4. It says for number 1 through 4, use the determinants that you found yesterday. And by yesterday, that just means the worksheet that we just got done doing. And then find the inverse of the given matrix. Let's call all this matrices matrix A. So just carry over everything that we did from the previous worksheet, because these are all the same. So you can just copy them down here. Determinant is 3. Second one is negative 23, 6, and 0. Right, all the same numbers. It's just that now we're going to go a little further and take that determinant and now move into finding inverse. Okay, AD minus BC, but we already found it, so we're just bringing it from the previous page. And now we're going to go through our inverse process. All right, any questions with 1? All right, try number 2. All right. Number 3. Oops, -4.6, my bad. Any questions? So in class on Monday, we will go through problems that are a little bit more involved. Okay, that will involve multiplication and a little bit more rearranging. But I want us to at least get comfortable with inverses before we jump into these more complex problems. So we'll look at the example from page 11 and as well as the problem from page 12. Okay. I'll also give you a quiz review that we can begin kind of preparing for our quiz, which will be on Wednesday. All right, if you don't have any questions, then we can end class here. Hope you guys have a great weekend. I'll see you guys on Monday.
Bye. Have a good day.
See you, Mr. Yang.
Thank you. Have a great day. Thank you.
Have a good weekend.
Have a good weekend.
Bye-bye.
Bye. Thank you.